This is Physics Lab 2, Motion of a Falling Object. My name is Henry Stewart. I'm a first year. Let's get into it. So, an introduction. This lab is designed to observe the motion of a falling object that is dropped from rest. The observed motion will be compared to two different simulations, one with the force of gravity and one with the force of gravity and drag. And then my hypothesis for this lab is that the simulation with drag will be closer to the observed motion than the simulation with just gravity. So let's get into some fundamental principles. So Newton's second law states that the net force is equal to the change in momentum over the change in time. So in this experiment, there is a net force from the drag force and the gravitational force. Next fundamental principle is the force of gravity, which is equal to mass times the gravitational constant. And here on Earth, it's 9.8 meters per second squared. So you multiply that by the mass of your object, and in my case, it is 7 grams, and the force is pointing down, as you can see with the arrow. Next is the force of drag, which is proportional to the square of the velocity. So you can see that B is the proportionality constant, and drag actually works in the opposite direction of velocity, and that's why there is a negative B in the equation. And then the net force is going to be equal to the two forces of drag and gravity together, and so it's pointing downward in our situation because gravity is larger than drag, at least at the start. So here we can check out the video of it falling, and we use tracker, and each dot is a different frame of the bag falling. So tracker does it pretty well, and as you can see, the graph of y over here is showing you the motion of y. So let's get into the graph of the three different motion observations. So the blue line is the observation, the video that you just saw, and then the red line is the simulation with drag and gravity, and then the yellow line is the simulation without drag. And as you can see, the simulation with drag is much closer to the observed data than the simulation with just gravity. So here we can see two important bits of code. This code is from the simulation with drag. As you can see, I have a B constant right here that is not 0, meaning that there is drag. And then I calculate drag and the force of gravity down here in the second bit, and then add them up together to find F net. Then we move on to the one without gravity. So I just make B 0, so it is as if there is no drag. So let's get into some questions. So which models, if any, predict a terminal velocity? So let's go back to the graph, and as you can see, the red line, it kind of levels out at the end. So there's a bit of a curve, but eventually it becomes straight. And that's because the force of gravity and the force of drag are actually equal in magnitude, but in opposite direction. So they are equal to each other, so there's no change in velocity. Hence a terminal velocity. Right? So let's imagine that the object was initially thrown downward. Would the terminal velocity in this case be the same or different from the case where the object was initially dropped from rest? So it would be the same, and we can see that with our simulation, if it had initial velocity going downward, as you can see, it levels out at the same velocity that it does with drag. So that's it.